So hello there, a new day, a new project. Today I want to present you my new pure sinus wave inverter. It's coming from Solartronics. It have 1000 watts of continuous power, 2000 watts for 20 milliseconds peak power. It's pure sinus, and that means that it can drive a fridge like this in a very proper way. Let's talk about what means a pure sinus wave. Okay, so in most of the cases, the mains power are looking like this. It's a perfect snake, call it, with 50 hertz or 60 in North America. We have in Europe 50 hertz, 230 volts. Okay, so this kind of pure sinus wave, it's perfect for running motors, compressors, of course, even vacuum cleaners, and so on. Of course, fridges and refrigerators and all these kinds of mechanism, using a motor. Because the motors, they really need this perfect sinusoidal wave. There is another kind of inverters, and those are called modified sine waves. Why? Because okay, there's the voltage here, and here we have the time, of course, in this. A modified sine wave, it's something like this. Going with a few steps. If there are a lot of steps, it should be nice. So somehow the sinusoidal wave, it's getting approximated. Okay, I hope you got the idea. So in most of the cases, this is absolutely okay. Running radios, TV, LED lamps, fluorescent lamps, classic bulbs, and so on. But here is a problem when we need to run motors. Some of the, okay, let me grab another piece of paper. So many modified sine waves, they are even simpler. Even going like this, a little bit of here, going up, then going down here, and down, and almost like a square wave. And that is not good for motors. The motors are not working this way. And if you have, let's say, a heating system and you need to run pumps, circulation pumps, those pumps are very critical for the circuit. You have hot water running through the whole installation, so it needs a really good sinusoidal wave for the pumps to work at their perfect efficiency and productivity in the same time. So at least for this kind of application, pure sinus wave, it's a need. And sometimes because the motors, I'm talking about the, let's say, direct driving motors, straight from the mains, because they don't have this sinus wave, they don't reach the efficiency, and they are pushing somehow, getting more power or sucking more power from the inverter, trying to keep the work, and can get burned very easy using this kind of modified sine waves, and they don't reach the power, they don't reach the random, they don't reach the characteristics. So that's why a sinus, it's a need. The point is that pure sinus inverters are more expensive than the modified sine waves, but I really recommend buying yourself a really good inverter, a sine wave inverter. It's totally different. This inverter can be used for running motor, pumps, all the electronics, like heating systems, and really need pure sinusoidal waveform. So it's a very nice construction. Solartronics, it's a German company. I've been using their products before. I had another variant of this inverter. It was 2000 watts continuous power, but for me now 1000 is more than enough. This is a kind of, let's call it, emergency inverter. I have my batteries down here. That the fridge, this little fridge, it's running on batteries for the last 3 days. Let me show you. In fact, we had a terrible weather here today, raining, almost no sunshine, and let me check the battery voltage here, but I still have 2.2 volts in the batteries, and that is really nice. Let's check if we have any consumption now. Oh, not yet, so the fridge is not working. This is a standby power around 600 milliamps on 12 volts. That means like maybe 0.6 times 12. Okay, so we are on now, and check it here. 38 amps, but for a very short period of time, and the machine is working as it should. And that this is not a reclama. This is something related to the things I'm buying and the things I'm using. Like I said before, Solartronics, it's a really serious German company. It's really raining outside. It's looking like a tropical storm almost. But I have no doubts the weather is really changed. We had a very short but very hot summer here on 47 parallel in the north hemisphere. Let's go back to this inverter. We got the fan over here, and these are the connectors for the battery. Good cables, strong cables. This should be a ground connector, and that's just a main switch. And let me have some technical details. So like I said, pure sine wave, high efficiency, 84 to 94%. 2 LED indicator, power green and fault, it's red. It has a loading temperature controlled and cooling fan. Microprocessor, of course, in the electronics. We have a input low voltage alarm and shutdown. I think it's like 10.4 volts. Short circuit, input over voltage, over temperature, reverse polarity, and it claims that it have an USB. So yes, we have a USB port for charging mobile phones, and 5 volts, 2.1 amps, and that's a nice touch. And what else? Let me see if we have a load now. Oh yes, 5 amps, 5.6 amps. That means that the fridge, it's running. Yes, it's running, I can feel that. That's it for today. Nice little machine, not too heavy, and like I said before, I bought this specially to have it mostly in emergency cases, when the power is off for maybe hours or days or something. At least I can run my heating and air conditioning system, but mostly the heating system needs a proper sinusoidal voltage. Okay, thank you for now. See you soon with some other projects. Please comment, like and subscribe. Don't forget to have fun, and bye bye.